Um, as an FYI, we will be recording this webinar today, and if you have any questions, you can address them to us with the panelist button at the chat button in the upper right-hand corner, and we will address them at the end. So I'm Jeff Whitehead. I'm the CTO and co-founder here at Zetta, and I've been in enterprise IT for about 20 years. And one of the areas that's always been of interest to me is disaster recovery and how do you plan for when the bad things happen. One thing we know about computers and machinery is that they always break, there's always bugs, there's always problems. And so it really comes down to what do you do under those scenarios? How do you prepare ahead of time? So that when the bad things happen, you're as ready as possible. So here's an overview of what we'll be going over. Number one is, why do we do disaster recovery? Two is, what is true disaster recovery? And I think there's a lot of things out in the market that are billed as disaster recovery, and I don't think they really meet the needs. The third part is a reality check to try to see, are you ready and prepared for this, for a disaster as it occurs? Then we'll have a demo and then a Q&A at the end. So one thing I want to point out is that most of you are probably, as IT professionals, are probably dealing with disaster recovery every day already. The most common is a user deletes a file or they drop their laptop and they need the files back. And that may not rise to the level of disaster for you, but for a user who's been working on a project all day and then lost it or for a week, that is a disaster for them. And that really is the most common use case. And if you go back in time when backups were a bunch of tapes that got sent off to Iron Mountain or some type of offsite facility, the IT people would kind of be like, well, do you really need that data back, or is it going to be hard for you to recreate it? Because those backup scenarios really didn't handle that most common use case very well, which is, hey, I need to get a single file or a single machine back. Sort of on the more serious end of the spectrum is when we have a whole server blow up. That's where you've got the server that's hosting application or servicing multiple users of the file share, and maybe its RAID array goes away, or maybe you get something like a crypto locker and it encrypts all the files there, and so you can't get access to those files anymore. And so that is more common certainly than the building burning down, but the least common scenario, complete site destruction. A lot of people think in terms of natural disaster, earthquake, fire, flood, that type of thing. Those are the most common for those complete site destruction scenarios, but there's also geopolitical risk. There's things like chemical spills that can happen if you're near railroad lines. There's regional power outages, and those are not the most common, but they are very, very impactful, even more so than a single server or a single laptop. So what I want to say is that true disaster recovery handles all three of these cases equally well. You can't be just great at the site blew up, but no good at restoring a single file, or vice versa. And you've got to be able to afford it. It's got to be something that you can manage on a day-to-day basis, and you've got to be able to afford it in terms of actual cash expenditure. So the reality check here is, do you have a true disaster recovery solution? I think most environments are actually pretty good at dealing, hindsight is 20/20, they're pretty good at dealing with disasters that have already occurred. But if you look at folks like Delta Airlines and more recently Southwest Airlines, they had pretty big disasters for things that should have been foreseeable and testable, because in one case they said a router went down, in the other case it was a quote unquote a power outage. And so the real reality check is, have you tested your disaster recovery plan? A lot of people think of backups in terms of it's backups not a backup until you've actually done a restore test. Well, I think it's the same thing for disaster recovery. You actually have to test your disaster recovery, not just think it through, but actually test it with your users. So one of the first things you really have to make sure is that your backups are off-site. One of the rules of thumb for backups is have 3 copies of any piece of important data in 2 locations, one of which is outside of the current physical facility. And it's not because that you have these regional disasters as often, it's because when it does happen, it's really, really bad. And one of the things that's interesting is that different governments and regional agencies provide these risk matrices for various communities, and I advise you to get them if you can. Another way to get them is sometimes through your insurers. But you know, some of the things that are on there, like influenza pandemic, are not things really that IT can provide for. So you really have to think about disaster recovery offsite in the context of, you know, you may not have any of the systems in the region, and you may not have the people available to work on the systems in that region either. So the other part of it is if it's not tested, it's really not a disaster recovery plan. And you should expect to find some holes the first time, whether it's your business process relies on funds transfers and you don't have a way of getting to the bank, or you actually have to, you know, physically move products, and if there was a regional disaster you couldn't get to UPS or FedEx. There's going to be some holes there, and they're not necessarily going to be all technology related, but there will be some that are technology related. And so what's important is to actually do a disaster recovery test, turn your DR systems on, and check it with your end users, make sure that it meets their understanding of the needs and requirements. Another part of it is that a lot of people think, well, I've got 50 servers over here, but in a disaster we can run on these 10. And for some applications that'll work, but in other applications it ends up being a very slow system. And you know, if you're only able to do half your business because you're in a degraded mode, you're not really all the way back up. You're really only half up. And one of the examples where this kind of falls down is that these appliances that are made for DR are really great for failing over a single machine, and they often have a lot of disk space, but they usually don't have enough CPU and RAM to fail over an entire rack of servers, or you can easily exceed the amount of capacity that they have from a performance point of view. Lastly, you've got to document your DR plan. This is required more and more by different compliance frameworks, but it's also important to realize that the person who's activating this DR plan may not be necessarily your A team. It may not be the people you pick to do the DR plan if you had all of your preferences. And so having it written down in a clean, easy to understand way so that anyone in your organization can implement or whoever is available can implement the DR plan is an important step. And lastly, you know, if it doesn't meet your needs, it's not disaster recovery. Ideally, find someone who's worked with your industry and has done the type of disaster recovery that you're looking for. And then one of the things I'll throw out there that I've seen as a particular gap for many implementations is the network and connectivity and VPN options. If you're using an appliance for failover, obviously if you're failing over offsite or failing over to a box that's next to a server, you don't have to worry about network connectivity. If you're failing over to an Azure or a public cloud provider, there's a whole host of things like, well, how do you set up a firewall for that? Are you just going to stick those servers, you know, unprotected, naked on the internet? That's not a very good idea. And then how do your end users actually get in and use those servers? So in particular, you know, network topology matters, and having a disaster recovery plan where your end users go to Starbucks and get on the Wi-Fi and VPN in is really not that bad of a plan for a lot of industries. But you have to have that VPN essentially set up ahead of time and have it documented in such a way that it's easier for them to do. You don't want to have to go by every single end user and get them set up in a disaster. You've already got enough headaches to deal with. So why did we build disaster recovery? Well, so our disaster recovery is essentially based on top of the backup imaging technology we've had in market for about 6 years now. And one of the things that we've noticed in this marketplace is that disaster recovery is new to a lot of people. And there's a lot of technology solutions out there that I call, you know, kind of table stakes, where they will let you fail over a machine or boot a VM somewhere else. But most environments have machines that need to talk to each other. They're not just, you know, a single machine. It's not just a QuickBooks on one server. It's usually there's a SQL server in there. Maybe there's a web server. Maybe there's an application server. And so you have to have that cluster of servers actually working together. They've got to have the resources available in terms of I/O capacity, CPU, network bandwidth. All those things have to be in place. And there's some amount of customization, I think, that it needs to be done to make DR work really well. Most IT environments are not cookie cutter. They look relatively unique. And so I think that applying a cookie cutter disaster recovery solution doesn't really yield a very good fit in most scenarios. The other thing I'll say is that we decided to tackle what I feel are some of the hard problems in terms of network accessibility and connectivity, you know, VPN, things like that. It turns out if you buy Site Recovery Manager from VMware or any of these very high-end enterprise replication products, you know, they say, well, go get a VPN from Cisco or Juniper, or, you know, have your network engineers design a solution for how to get into it once you fail it over to this other site. And, you know, if you're a big enterprise, you can afford that and do that. But for most of the folks that we see in small, medium enterprise, or even some relatively sophisticated customers, don't want to have to buy a whole stack of equipment just for their DR. And really the design for this at the end of the day was, we want to be the data center provider for people who don't have a data center, or for people who have a single data center, we want to be the second data center so that you can fail over and actually run your applications and do it with all the fit, function, and features that you had in your original deployment. So this is a quick diagram that sort of shows how we do our disaster recovery. It is as simple as back up a machine. You can poke a button and we can boot it right away. One of the things that's a little bit different about us is because we have the images essentially sitting there ready to go on the virtualization storage, you can boot the machines in roughly the same time it would take to boot a VM locally. So they boot up in less than 5 minutes. We have some DR testing where we can boot it up and take a screenshot that'll be available in Q4. Unlimited scalability really, I think, is the key here. If you've got 5 machines, we can give you the capacity for the 5 machines. And you know, the 5 machines can have a lot of variants. They could be 8 gig machines, or they could be 128 or 384 gig machines. So we can support a wide range of requirements, both in terms of per machine as well as for your whole site capacity. And then the other thing that we have that we're wrapping around this is our people. And so I've got Harlow Sinch here, who's our director of support, and he'll be talking through the demo in a little bit. But we have engineer level support people who are available 24/7 to help you with the initial setup, and then should a disaster occur, we'll actually work through it with you guys to make sure that it works. And that's for backup, the actual failover in the event of disaster, and then failback. And we also offer things like Active Directory integration, pretty common thing to have Active Directory, but we go the extra steps and we'll integrate that with our VPN solution such that your end users can authenticate to the VPN with the credentials they already have. What makes us really different, I think, is that it's 100% cloud-based, and when we provision a customer, we provision them a virtual private cloud ahead of time. So you get a network with some public IP addresses. You get a firewall that you can configure. It's very much like a Netgear firewall where you can set up rules and port forwards and things like that. And you also get a couple of different VPN options. We support site-to-site VPN with our virtual appliance at your end with NVGRE, or you can use your own VPN box if you have one. We just provide point-to-site VPN with a SSL-based VPN. That's where your end users load a piece of software and they can VPN in from wherever they are. And we also support IP takeover, and that's where we have a virtual appliance that sits in your network. And if you have a rack full of servers, but only one of them dies, it can actually take over that IP address and have any packets that are bound for it, send that across the tunnel and have it hit the replica that we have running, or the failover copy that we have running in the customer's virtual private cloud. So now we'll transition to the demo. I'm going to stop sharing, pause the share for a minute, and hand it over to Harlow. We're just logging into our portal right now.
All right, we're going to start here on the main page of the Zetta portal. This is our dashboard you see when you first log in. This page gives you a quick status of all the VMs, all the images, servers you have backed up. You can see when they were last backed up. You can see which ones are currently enabled for DR. You can see which ones are available to be enabled for DR. Configure the systems. This is where we come in. We choose the different retention options, how many versions of the server you want. Throttling if needed, the various backup tasks, and you also can check a historical status. You can see the last week's worth of syncs at a quick glance. You can see, the whole environment and what your backup looks like. And then we're going to go ahead and jump into the DR tab, which is what most of you are here to see. This page gives you a nice list of the current available VMs. You can see down here there's a list of active VMs and idle VMs. Active VMs are images that are already powered on in the Zetta cloud. And the idle VMs are ones that have already been configured for DR, but they're not currently powered on. So to turn one on, you would go down here. You just click on the Activate button. You'll get a dialog which lets you choose which version. In this case, I'm going to go ahead and restore to the Saturday version of this one. And then while that's powering on, at the top, you can see we've got the two different VPN options, which Jeff was just talking about. One would be the point-to-site. This would be something you install on individual laptops ahead of time. You can log in from home. You can connect to the cloud from Starbucks, anywhere you have network activity. And you'll be able to VPN in with that. Then you can RDP. You can access applications running on your servers. And then the connect site to site would be the option you would use to connect your office LAN to our cloud. That would allow, if you have, say, 10 servers set up with us, but only one of them has failed, that would allow you to power the one up in the cloud, and it would still be able to interact with applications running on other machines locally on your LAN. This prevents you from having to enable the entire environment just to access one machine. Once machines are powered up in the cloud, you have remote console access to them. You can get your applications going. So we're going to go ahead and log into one of them. You click the remote console button. You'll get a little pop-up here that gives you your credentials to log into it. Sorry, one second. We're still powering on the VM here. I didn't notice it was still activating. So that can take anywhere from 1 to about 5 minutes, depending on the size of the image. This option up here will give you the port forwarding that Jeff was talking about. We can take a look at that in a moment when the VM is done powering up, but that'll let you set up port forwarding. So if I were to say power up a web server or mail server in the cloud, I could then enable port 25 to allow the mail to come through, or now enable the web access port to allow web traffic into the one machine.
And after today, we're actually doing a release later today. It'll actually say virtual firewall configuration instead of port forwarding. Looks like we just activated.
Yeah. So once the machine is activated in the cloud, we can come up in here, and we're going to go and hit remote console. You'll get the dialog box I was looking at. You'll just want to copy the password from it. And then you click the RDP link that's provided and just enter the password. And just a couple seconds, it'll load up RDP session into the machine. Once it's up, we'll be able to access the SQL Manager, log into the local machine.
It's worth noting this is a RDP session for the console. So even if your network configuration is messed up or something went awry in the activation, this is a true console, just as if you plugged in a keyboard, mouse, and monitor directly into the machine, but delivered virtually. So this will be the version of the machine running from
whatever version I've chosen. In this case, it was the Saturday version. Once it's up, you have the full access to the Windows machine. Any of the applications that run on it, in this case, this is a SQL machine, so we can open up SQL Studio. All of our databases would be up from that version. At the point, if I had the site-to-site VPN up, my desktop on the LAN could connect to the database on the server if necessary, and I'd be able to do everything, business as usual at that point. I'd be back up and running. Let me go ahead and just jump back to the portal here. All right, and then the last thing I wanted to show is what the network configuration looked like. So we can open up this tab. It's very similar to a home router, kept it very simple. In this case, I've got a rule set up for my web server. This is the external IP, which doesn't change, so I can have DNS pre-configured on my end. Port 80 is enabled, and this is the internal IP for that machine. Same thing, mail. I've got port 25 forwarding to the other machine, and you're up and running.
All right, thank you, Harlow. So now we'll turn it over to the Q&A, but before then, I will mention that this is the backup is not a new product for us. We've been in the market for a long time. Disaster recovery offered, as you've seen here, is a little bit new, but we actually have now turned it on and used it for customers in real disaster scenarios. So it's a little bit more than a beta. It's a real product now. And the other thing I want to point out is that we support physical and virtual hosts as source machines. And the way that works is we do an on-the-fly P2V or V2V translation every time we do a backup. And so you can back up your VMware machines and boot it in our fabric. You can back up your VMware machines and restore it to Hyper-V. You can back up your Hyper-V and restore it to VMware, and of course physical to any of the virtualization platforms as well. So that's kind of a cool feature that we snuck in there. The other thing that's worth noting is that you can also do, if you don't want to activate a machine, you can still do things like single file restore out of a virtual machine or image without having to boot it up, or you can also do so once you booted it up. So I'll see from Julie here if we have any questions.
We do. We have a few that have come in. The first step is from Warren. Can I spin up a server configured in IIS farm, also SQL DB clusters?
So DB clusters that require shared storage is not something we support right now, and I'm not sure about IIS farm. I think it should be doable, but this is one of those scenarios where we'd say, let's go ahead and try it. Our virtualization fabric is Hyper-V, so if you understand how to deploy a system in Hyper-V to do what you're trying to do, we can duplicate that on our end. But that's one of those kind of more custom configurations where we would want to work with you and set that up and validate it ahead of time so you actually know you've got a disaster recovery solution you can rely on before the disaster occurs.
So next up, what's the first thing or the one thing that you've seen IT professionals miss when it comes to disaster recovery planning?
Well, there's a lot more than one thing that I've seen be missed when it comes to disaster recovery planning. In particular, I see that documentation goes out of date relatively rapidly. Even if you put together a great DR plan, Microsoft puts out Windows 10 update, anniversary edition, and something works differently. And so your documentation, while probably still fine for the IT professional, is probably not sufficient for the more layperson who might be having to do a disaster recovery activation. The other thing I've seen where it really falls down is only thinking in terms of systems and not thinking in terms of users. If you don't think about how people are going to get how do you get a hold of your people? How do you get the instructions to them how to get onto the network and fail over? If their email is down, obviously you can't email them. So there's a lot of merit in having a phone tree that's printed out on paper so you can call people and get information out. But yeah, that's sort of the main area is as IT people, we tend to think in terms of applications and systems, but think in terms of what the user is trying to do every day, whether it's, ship and receive packages or cash checks or, write physical letters. It doesn't really matter what it is, that business process needs to continue, not just the IT stuff.
So we've got quite a few questions coming in. How do I get the data back once the old site comes back online?
Sure. So you'll notice with a lot of other DI providers, they're like, you can only activate this for 2 weeks, and then we're going to start charging you after that. So my philosophy is that, look, you've just had a disaster. I'm sure you've got plenty of things to deal with. We would like to get you back on your own hardware as soon as possible. But in the meantime, this is up, this is running. Hopefully it's meeting your needs. Worry about the bigger fish first. So when it is time to bring it back, basically what we do is you do a download of the image. And because that takes a while, that image is essentially old at that point in time. And then you can do any number of incremental restores that brings it closer and closer to current. And then at some point you have to say, okay, I'm actually going to cut over back to my local server. So you shut down the server in our cloud. It does take a downtime. You bring back that last set of changes locally and then activate your local machine.
So how does this differ from replications in Veeam?
Well, it's a little bit different in replication from Veeam. Well, it's always a little bit dangerous when I'm talking about someone else's product. First of all, I think the activation time is pretty different. I think Veeam's good at a lot of things, but for the most part, I'm not sure if they provide a managed solution. Maybe they do through resellers, and I certainly don't think that they provide a completely cloud-only option where they sync directly to the cloud. Maybe they do. I'm not going to opine too much about a competitor's product. I prefer to stand on our own 2 feet. But Veeam is, if you're all virtual, I think Veeam's a pretty good product.
If I have DNS in my location and fixed IP addresses, how difficult is it to actually change the IP addresses subnet to make sure all of my apps work?
Well, that's going to depend on what your DNS framework is. For the most part, what we can do is say you're 10.1.1 locally, we can set up our virtual cloud to be 10.2.2 or 10.2.1 locally. And we can set it up to be anything you want as long as it's not overlapping. My advice to you would be to set up the DNS mapping ahead of time and have the servers running in the virtual private cloud. The point being that when you have a failover event, until then nothing would be pointing at them essentially, and so once you point at them, they'd start returning the correct failed over results.
How does IP address takeover work?
IP address takeover works by, we have a virtual networking appliance that you run on your segment, and what it does is there'll be a button in our portal where you can basically say, take over this IP address for this machine. So you activate the machine, we send down a configuration payload to that virtual networking appliance, and it configures itself to take over that IP address. And what it does is then it stuffs any packets bound to that IP address across the tunnel. It's basically like a NAT at that point, where it then shows up at the machine running in the virtual private cloud. So it's very much like failover, where it's actually taking over the IP address. And it's really designed for that case where you've got a whole rack of servers, but only one of them has failed, as opposed to like the whole site has failed.
My need is bare metal backup. Will this work for me?
This absolutely works for bare metal backup. For the restores, bare metal restore is a bit of a problem in that I found that a lot of people do a lot of work in terms of driver injection and things like that. But if you've had your building burned down, you buy a brand new server, it often has a brand new NIC in it, and there won't be drivers to inject for it to make that work properly. So what I recommend for most people is that since we're virtualizing everything as part and parcel of our standard image backups, I'd recommend that you bring your images back as virtual machines and sort of say, great, you know, we've restored and we've modernized. We're now running as a virtual machine as well. If you don't want to do that, with our support, we can walk you through the process of doing a bare metal restore as well. But we are absolutely, I think, one of the best at backing up physical servers across the WAN, certainly.
That's it. Actually, one more just came in. Can I get the virtual machine back in the format I need, VMware, etc.? Yeah,
so our client, we actually use our own independent format, and so you can restore things as a VHD, VHDX, or VMDK, or as a raw image. And so it's going to be able to be booted in any of the virtualization platforms, even VirtualBox. If you've got a a very small deployment, VirtualBox will work for the way we're doing our images as well. All right, well, that's it. So thank you for joining us. And my email address was at the beginning of the presentation. I'll just power back to it. I do read and respond to email. So if you have any questions, go ahead and shoot me an email. And thank you for joining us this morning.